So my name is Carlos Lopez. I work for the Swedish Energy Agency. And I have the pleasure to welcome you to this workshop on the contribution of Ecodesign to improve the energy efficiency of systems. So, and I do it on behalf of the eceee, that is the main organizer. That's mainly Niels Borg that has been doing a lot of the work, and also Edouard Toulouse, and also the sponsors. And the sponsors, you have them on this slide. And I would like to add also the State of Baden-Württemberg. So we all know that Ecodesign has been very, very successful in providing and originating savings, but it's especially on products, and then it includes also components, some functions like standby, and some simple products, and now more and more complex products. For example, the ones that were voted in December, transformers, huge transformers, and central ventilation units that are part of very complex systems already. Ecodesign and labeling have originating savings up to 2,000 terawatt-hours of primary energy, according to the European Commission, per year from, let's say, 10 years from now. So it's very huge savings. But we know that there is much more that we can save. And that's the rest that we can save. It's mainly more on systems. So the problem is that we can use a very efficient product in a very inefficient system. But the challenges are enormous. And we have to start to discuss how to regulate systems where there are no policy instruments addressing them. So the pretension, we don't have the ambition that Ecodesign is going to solve the question. But what we want to discuss today, to start the discussion, the reflection, is what is the contribution that Ecodesign can give and how it can interact with all other policy instruments. What we know also is that it has to be, a system is always different. So we have to, the solution will be different for every situation. And that's why we have two main areas today. We have buildings and lighting systems. For buildings, we have quite a lot of regulation already, mainly the EPBD, and also many years of national regulation. We have also lots of product regulation, but in many cases, there are no regulation for systems, for technical systems. Then we have a sector where we have maybe more problems is the industrial sector, where it's much more difficult to have regulations as we have for buildings. So we will have a session on motor systems and all kinds of products and systems that use motors, like compressors and pumps. So for each area, we'll have three main challenges. The first challenge is what to regulate and how to formulate the requirements. The second challenge is how can we ensure the compatibility between the components, the products that will be integrated in a system. And that brings us to a great need for standardization and other methods. The third challenge is how to perform market surveillance as we go from simple products to more complex products and eventually to systems. To launch this discussion, we have invited, and we are very happy that they have accepted, the European Commission, some member states, the industry representatives, and also some of the best experts in EU, but also from the US. And thank you, Alan. And thank you for accepting the challenge of launching the discussion without maybe presenting already the solutions for that. And of course, we would like to thank all the participants. I think that we were very successful in getting so many participants. and I wish you a very fruitful day. Thank you.
So, hello and welcome also from my side. My name is Sibylle Braungart. I'm working at Fraunhofer Institute for Systems and Innovation Research in Karlsruhe in Germany, and I will be moderating today's seminar. So it's a great pleasure to be here. I'm very much looking forward to the presentations, but before starting I have a few organizational remarks. The first thing is, today we have an introductory speech by Niels Borg, and then we have 2 sessions on opportunities in buildings and lighting. At the end of each of the sessions, we have time for question and answers. So the idea is that we first listen to all the presentations and then we collect the questions. If you have a very urgent question that you really need to ask right after presentation in order to understand it, you can do this, but in principle, we collect the questions after the presentations. And then also, whenever you ask a question, I would like to ask you to say your name and institution before. All the presentations will be filmed, and the films and also the presentations will be online. The presentations probably later this week or early next week, and the films a little later. So I would say we start right away with the first presentation. This is Niels Borg from eceee, who will talk. His title is From Products to Systems, Overview of Energy Saving Potentials in Systems and Main Challenges to Grasp Them.
Yeah, Alan will speak more about user interaction with things like this, and I just wanted to show you, to make a pitch for Alan. Otherwise, I know how to do it. Anyway, first of all, I must say big thanks to Edouard who helped me put this together and collect the information on what we can do with systems. And although I knew how much we can do, I'm still very impressed by the numbers when you see them all nicely put together in one presentation, as you will see. First, very shortly about eceee. Most of you know us, but we are an European membership-based NGO, and in that sense we are different from most other NGOs because we're an association with members, with both organizations but also individual members. One of our aims is to establish evidence-based knowledge on energy efficiency. So we do the summer studies, but also seminars and workshops like this to generate and share and disseminate information. We have our website, of course, and the Ecodesign portal, which I hope most of you know, all of you know. The summer study, our first summer study, the traditional one, we have been doing that actually since 1993. And so we had a 20-year anniversary this summer that just passed, and we are now doing an industrial summer study since we're going to have our second one in June. So do join, especially if you're interested in industrial systems, please join us there. There's a little brochure out there, but go to the website and do sign up. The early bird registrations running out next Friday. So, systems. I think one thing that is happening is that we are moving from products to system, not only on motors and things. More and more things are becoming networked, are becoming integrated with the systems, and that is a big challenge. So I'm going to run through a number of examples. One of buildings, for instance. This is an example from London, from Imperial College, where you looked at the balancing dampers and how the left one shows the normal pattern of energy use over a week, night and day. And then after the retrofit, when you went in and you checked, you see there are much lower valleys. So you managed to really turn things off during night and when they're not used. And those things saved about 60,000 euro a year just by optimizing the system. The potential for residential and service buildings in HVAC, so heating, cooling, and ventilation, is really impressive. The top chart, the top bar here, is the expected annual consumption by 2020. And I'm going to explain just with this one how the numbers are, so you don't have to sit and scratch your head because it's the same way all through the presentation. So you have, just by improving equipment, the efficacy of the various units we put in. We could probably save around 70 million ton oil equivalents, and that is a 15% saving. If we work with building management systems, the total savings are instead 28% by 2020. But the numbers in oil equivalents are the additional you get. So this is the way we put them in all of them. So it is consistent. So the percentage are the cumulative percentages. Let's look at lighting, which I'm very fond of. And here is an example from USA, where you have a storehouse, a warehouse, where just by changing to LEDs, you had metal halide and having LEDs, which are not per se more efficient than metal halide really, but you can direct them, you can create more efficient lighting, you can save 50%. But LEDs provide the opportunity to work with the controls, and then you can cut really much, so the total savings are about 93%. This is from a garage in Stockholm, under my building, where you don't need LEDs. So I wanted to show this because this was done 6 years ago, and we saved about 95% of the electricity in the garage. Because these are fluorescent lighting, it's dimmable lighting, and it's occupancy sensor. So it dims down instead of switching it on and off, and then it turns it off after a while, and you could save 95% even with sort of old traditional existing technology. So there's not that we have to wait for the most advanced technology. No, it was very new. It doesn't look that nice nowadays. Tertiary lighting. I'm not going into domestic or residential lighting. By 2020, about 200 terawatt hours. Just by improving the efficacy of the light source, of generating the light, so to say, 25 terawatt hours, or 13%. If we start to work with the luminaires, you could get a total saving of about 35%. But again, looking at lighting systems, controls, optimizing them, there we really can catch in on the big savings, almost 60% compared to the 2020 scenario. Industrial processes. I had to add this picture because I didn't really know what the factory was about. This is not an industrial process, but you can do this carding. You can do it industrial as well. So this is an example from, I think from Austria, where you have a carding factory. And carding has a definition, which is a mechanical process that breaks up fiber logs and aligns the fibers. That is, you have a heap of wool and you can make nice cloth or thread. Anyway, just by improving the machinery, you can save 50%, which is nice. But again, looking into the auxiliary system or the peripheral systems, you can save another 20% of the electricity, and also there's heat recovery gains to be made, so you can do a lot. Again, at looking at the systems approach. Motor-driven system is one of the very big prizes in the Ecodesign regulation. There's a lot of energy, and we can do a lot. By improving the efficacy or the efficiency of the system, so the motor itself and also variable speed drives and so on, you can get some 30 to 50%, which is great, very impressive. But if you take it one step further, by optimizing the whole system, the flow, this is from the IEA 4E motor systems annex, their work. For instance, smaller motors and really working on really where a motor is needed. You can get another, 20 to 50%. So I don't know exactly how they changed, because 50 plus 50 should be 100, and I don't think that's what they intended. But I'm not really sure how the example is given here. But anyway, the point is, again, moving towards systems can give you very, very large savings. Pumps, I think, is one of the most interesting examples in the sense that by improving the product alone, you don't get that much, a few percent. It's still a lot of energy. It's about this, an average size nuclear reactor in Europe. So it's not. It's something. But with speed drives, you get 30% from the total potential, And then again, working with system optimization, you can cut pump energy use almost down to half. So again, that is a very large potential. ICT networks, that is something that is growing a lot, and Alan will speak a bit about that as well. And there it's to really, you can do something with the products out of powering down of products, scaling the network power in proportion to what is really needed, because we have a lot of oversizing, of course, and also how the components speak with each other. They chatter a lot. It's really a lot of nonsense going on in communication protocols, and especially if you look at advanced set-top boxes, we all know that they consume a lot because they keep chattering with each other all the time. Here the consumption are estimated again at 260 terawatt hours by 2020. If we improve equipment alone, that's still a lot to do, 17%. But the optimization, the estimate, is very hard to estimate this. I think everything is hard to estimate, but this is probably particularly hard because so much is happening so quickly and there's so many products and so many gadgets. But, you know, in the order of 35% or more. This is one of the best images I've seen for a long time, and I'm really grateful for Edward to making this, because the gray half is of these 4 products that I've shown, our building systems, lighting system, pump system, and IT networks. This is what we have gained already in savings from the Ecodesign regulations we have adopted so far. But still, we have the same amount of savings out there which we need to catch by getting after the system optimization and system regulation. So the same products, we have another piece of the cake which is equally big. So I think that is something very important to look at and to think. So this is really what we are talking about here today. How do we get this? A few policy recommendations. There has been a few studies looking into this, but one of the, probably the best one so far, giving the best overall view, is one that BRE did for DEFRA in 2011. And they make a number of policy recommendations. I'm not sure, I haven't thought about them so much so I can say, yes, these are exactly what we need to do, but I think they all make sense. So, of course, we should identify what functions and what the potentials are, so we know where we should go for. This is already what is being done in the normal eco-design process. You know, we don't regulate toasters, for instance, which was an example in Sweden by the electricity industry that said you can go of regulating toasters but not transformers, which was actually a stupid example because we are not regulating toasters because they're not significant. Decide what type and level of intervention is practicable. What should we do? What is the practical thing to do? The other thing, the third thing they say, really look at what are the benchmarks so we know where we are going for. What is really realistic to do? Then we need to check something if there are potential with existing legislation, because there may be other regulations that conflict or that maybe does part of the job. So I think it's important to have an idea of this. Then define the system, and the word extended product approach is debated, and I don't want to go into a debate if that is what we're going to call it in the methodology, but call it extended product approach or systems approach or whatever, but at least define the system so we know what we're speaking about. I think that is very important. And then justify the choice of the system versus the product component. We need to know why we're doing this and not that. So it's not just haphazard. To implement this, the first advice this DEFRA study gives is to develop the methodology and the measurement how we should evaluate the performance. And that, I think, is a really crucial part. It's more tricky than most of us understand, I think. And if possible, can we have a single index of performance? I'm not sure it's always possible, but I think that would be it's something we would like to see. Ensure that evaluation is based on installed conditions. So I'd say let's make sure it's realistic. That's what it's all about. And identify critical aspects of design, installation, and maintenance, because these are systems, again, I think in Ella's presentation, we'll very much look into the user interface, that they are used and they're maintained in the right way. The requirements for inspection, measurement, and replacement. So when does it make sense to really throw out something old and put in something new? And guidance and training, to have people who actually know how to use them. That's increasingly, I would say more than, it's really important in systems, because it's more complex. It's not just one gadget you buy. Even a gadget need or a standalone thing needs to be maintained, but the systems, it's kind of a factor of two where you get things that are going to work together with each other. So that's very important. And the last one is then to promote and then review the scheme regularly, but which is true for all eco-design regulation, of course, and everything we are dealing with here. So that was the overview of what we can make. Of course, there is a lot to get. I'm sure you will hear from all the different presenters on the various areas again, and I think that is a message that needs to be repeated. So just to set the scene, and I'm looking very much forward to hear about the expert on the various areas. Thank you.
Welcome everybody in the representation of the State of Baden-Württemberg to the European Union. I would like to welcome you all also on behalf of our Minister on the Bundesrat, European Integration and International Affairs, Peter Friedrich. And well, we are delighted to host your conference here. A special welcome to Mrs. Braungart and Mrs. Schlomann from Fraunhofer ISI in Baden-Württemberg, and to all your partners and participants here of today's conference. Well, we are aware that our region, the state of Baden-Württemberg, is often considered to be one of the so-called advanced regions in Europe, one of the regions which is based on manufacturing, engineering, applied science, and we're always pointing out that our region is one of the regions which is highly globalized, one of the globalized, perhaps one of the most globalized regions in European Union, and most of our citizens and most of our researchers and people in economy are aware that the region is making a big profit of globalization. But there are a lot of tasks in front of us, and we think that the things you're occupied today with and in your daily work, in your institutes and wherever, struggling for more efficiency, struggling for more effects concerning what we're calling today the low-carbon economy, or the so-called German Energiewende. Everything which is around these topics is your main business, and therefore we appreciate you being here and organizing your conference here in our premises. We hope you have good success, and I think this is in the sense of all of us, that you're going ahead in your daily work, struggling for all the topics you're discussing today. So we think this is the right place to discuss these things and to show some success on the way to the future of low-carbon economy, of more efficiency, and so on. Well, thank you for being here once again, and have a good time in our premises. Thanks.
Thank you very much. Especially thanks also for giving us the possibility to have the conference here.